Hello students, I am here with probably the last video on the circular motion. Okay, so we are on to exercise 15C and I'm going to try question number 6 with you. Now the question says the question is that there is a particle of mass 3 kg. It is resting inside of a smooth circular hoop of radius 2 meters. Okay, and the particle is projected horizontally with the speed 8 meter per second. Find the greatest height achieved by the particle from the point where it is projected. Okay, so we are projecting this particle from this point over here, and we're giving this the initial speed of 8 meter per second. So you see that there is a condition for which under which a particle can complete the vertical circles. If you recall that, the condition is that u should be greater than or equal to 5gr. So right now we have the radius, which is 2 meters over here. So if I use that, this is 50 into 2 is 100. So if the initial speed is going to be, like in this case, if it is more 10 or more than 10, only then this particle complete the circle. Okay, so right now we're given the initial speed as 8 meter per second. So what do you think? Will this particle complete the vertical circle? Yeah, not obviously. So this would if it moves like in this vertical circle, so this will not be able to reach at this point. It will somewhere, if I just name this point as this is the point A, and if this is the point B, so while moving from A to B, this will definitely lose contact from this circular surface. Okay, so now what will happen when this will lose the contact? Okay, I'll tell you that later. First, let's see that up to up to what angle this will be able to rotate during this circular motion. Okay, so now as you know that we always have the initial the energies initially and the energies generally. So at this level, you see, we determine the energies from this level. So this is the level where the potential energy is meant to be 0. Okay, so initially we have the potential energy as its mass is given 3 kg. So this is from this is 2 meters below, this is the point O, so A is 2 meters below O, so the height is -2 right now. So the potential energy over here initially is going to be, if I use that minus mgh, so that is going to be -60 joules. Okay, and the kinetic energy initially would be half mu square. So u over here is 8, so that is going to be half into m is 3 and 8 square is 64. So this is going to be 96 joules. Okay, so this is the these are the energies initially. We have the potential energy -60 joule and the kinetic energy 96 joule. Now let's see what it's in general, what would be the energies generally. So if I just take a point over here, and this has been rotated theta degrees over here, so here is that particle with me. I have to show its weight. The weight is going to be 30 newtons. Okay, so this is going to be R because this is in contact with the surface over here, and I will have to determine, like over here, the speed is going to be V. Okay, so the speed is V. Now let's find this length. We know that the radius is 2, so I'm just going to write 2 over here. So this length is going to be 2 cos theta. This is going to be 2 cos theta. So right now, to determine the potential energy, the height is going to be -2 cos theta. So let me write that generally we have Now the potential energy, it depends on the value of theta, that is going to be minus 60 cos theta. So you see that why it is minus 60, because mg mass is 3 into 10 and then into 2 cos theta, so we get minus 60 cos theta. And the kinetic energy in general is going to be half into mass is 3, half into this is going to be 3v square over 2. So now if using the conservation of energy thing over here, the sum of the energies initially, which is going to be this potential energy and this kinetic energy. So when I sum these two energies up, I get 36 joules, okay? And when I sum up the energies in general, so I have minus 60 cos theta and plus 3v square over 2. So I take out the value of this 3v square over 2. Guess why I am finding this 3v square over 2? Yes? Any guesses? Yeah, because you know, if I use that F equal to ma principle over here, so you will see that this m is 3 and this will be changed with v square over r. So that would be same as 3v square over 2, okay? So this is going to be 3v square over 2. Now let's see that what would be the left hand side over here, okay? Now when I resolve, like, you know, this weight in a direction so that I can determine this net force towards the center. So this is the theta over here, and you see that this is going to be 30 cos theta. That is the component of the weight in the direction towards the center. So this will be over here, this will be r minus 30 cos theta. You see, this is r minus 30 cos theta. So now you see that within this frame there is this is giving you, let me name this as 1 and this is 2. So from the relations 1 and 2 we can have a relation between this r and theta thing, okay? So this would be r minus 30 cos theta, that will be equal to 36 plus 60 cos theta. You see that? Okay. Now what will happen now while moving on this circular track inside the circular thing, when it will lose contact, what will happen? What will happen to the value of r? So r will be, like, suppose like, you know, on this circular track, like moving over here, so when it loses contact with the surface, then you have to put your r equal to 0. So we shall put r equal to 0 over here. So I'll have this that would be 60 cos theta, so sorry, 90 cos theta, that is equal to minus 36, okay? So this cos theta over here is minus 36 over 90, which is going to be minus 2 over 5. And if I find this theta, so this theta is 113.6. Now this becomes very clear that like, you know, while starting from here, this is going to be 90 degrees, and I think when it reaches to this position, this will lose contact with this circular surface over here. Now what will happen when it will lose contact with the this surface over here? Now instead of moving in circular track, this will be moving under gravity now, like this. Okay, you see, and this would become a case of the projectile kind of a scenario over here. Okay, so now we have found that this angle over here is because this whole angle from this position to this position, this is, we have just calculated this is 113.6. so you should allow me to write that this angle is 23.6 degrees. So now we are going to coming out of the circular motion, and now we shall see that since we have to find the greatest height of this object when it starts from this point A. So how to do that? Now let's start finding the greatest height. To find that height, I need to know that when it just lost contact with this circular surface, so what was its speed at that moment. Okay, so I can use this first equation over here. I can put the value of theta, in fact cos theta, into it, and I'll be able to find the speed the moment it loses contact with this circular surface. Okay, so let me write this as 3v square over 2, that is equal to 36 plus 60 cos theta. So instead of cos theta, I should write this minus 2 over 5. So this is minus 2 over 5. Okay, so now this will give me v square equal to 8, and then v is equal to the square root of 8. Okay, now so this speed at the moment is going to be 8. Now we have to resolve this speed into its vertical and horizontal components, okay, so that we can deal with this projectile situation over here. So since we have to find the greatest height, so I need to know that what is the vertical component of this velocity right now. Okay, so I have to see that if this is the highest point, that how much is this distance. You see, we know that this distance is 2. Okay, you can find this distance over here because this is going to be 2 again. So this is going to be 2 sine 23.6. okay, now we just need this distance over here. Let me name as S. Okay, so I have to find the vertical component of the speed over here. That will become my initial velocity for the part of the journey where it is moving purely under gravity, and this is a projectile kind of a thing. Okay, we are quite sure that here that Vy will be equal to 0, because when it reaches the highest point, then its Vy has to be 0. Okay, now if I resolve it like, you know, this one here, this is going to be the vertical, sorry, this is the vertical component, and this one is the horizontal component. Okay, we know that this is V. Now this is 23.6, this is going to be 23.6. okay, and this angle would be 90 minus 23.6, and then this further, this would be 23.6, and then you should allow me to write that this is going to be under root 8 cos 23.6. okay, so this is your vertical component of the velocity right now. Now this becomes the initial speed for the part when it is purely moving under gravity. This is not in the circular motion now. Okay, so we have the initial velocity over here, that is under root 8 cos 23.6. we have the Vy equal to 0. We have the acceleration minus 10, and then you can find this through 2as, that is equal to v square minus u square. You will get this s value over here. Okay, so you add this value, the value like 1, the first value, this is the second value, and then plus this is the third value. So these three, this plus this plus this, will give you the maximum height of the object, maximum height obtained by this object. Okay.